Good afternoon, sir.
Good afternoon. Good afternoon.
Hello.
Shall we start?
Hello.
Good
Good afternoon.
Hey, good afternoon, Santosh.
How are you?
Good. Shall we start?
So, shall we start, Dr. Rajashankar?
Yeah, Bharti.
Yes, sir, I'm here, sir. If the chief guests are there, then we can start the function, sir.
Yeah, chief guest and
all
guest
are
of
there.
honor. Guest
Yeah,
of
all are
honor. No,
Yeah,
no, guest of honor and our chief guest, Dr. Vannazurai. Can
they
they?
are there, sir, already.
No, they can switch on the video. Probably our Director General can see, no?
Dr. Annadurai?
Hello?
Are you here?
Yeah.
Yes.
Oh, good to see you.
Okay.
Yeah.
Dr.
So
Purnima Jali.
I hope, I'm sure you have heard of him. He's that on the line person who's, that which was enacted by our, what is his name? This film, Hindi film, Akshay Kumar. His role was enacted. So that is he's extremely popular in Tamil Nadu. And he is currently the Vice President of Tamil Nadu State Council for Science and Technology after retiring from IISF. So he is here, settled here. So I saw him in CLRI. He had come and given an excellent talk. So I thought he will be the right person to popularize this IISF today. Anyhow, so let's start. What about Dr. Purnima?
Yes, I'm here. Can you see me? Namaste.
Yes. How are you, madam?
I'm fine, thank you. Thanks for inviting me. Can you hear me?
Yes.
Okay. Namaskar.
Okay, Bharti, we
Sir,
can.
yes, sir. Yeah. Very good evening to one and all who have joined here. Chief guest of today's function, Dr. Mailswamy Annadurai, Vice President, Tamil Nadu State Council for Science and Technology. Guest of honor, Dr. Purnima Jalihal, Director, NIOT. Dr. Shekhar Mande, DG CSIR and Secretary, DSIR. Professor Santosh Kapuria, Director, CSIR, SCRC and Coordinating Director, CMC. Shri Bhagwan, Nodal Officer, IISF, CSIR, SCRC. Invitees, colleagues, friends, I, Bharti Priya, on behalf of CSIR, SCRC, welcome you all to Dr. Abdul Kalam Vigyan Yatra, curtain raiser event for one of the main science event of India International Science Festival 2020. IISF is an annual event organized jointly by science and technology related ministries and departments of the Government of India and Vigyan Bharati, shortly called VIBA. The theme of this year's IISF is Science for Self-Reliant India and Global Welfare. It is a festival to celebrate science to the public and to showcase the ways how science, technology, engineering, and mathematics provide solutions to improve people's life. This is all the more relevant to the current scenario of living amidst a pandemic. Thanks to STEM, we are overcoming successfully the pedagogical crisis created by the pandemic in learning and teaching using the advanced technological and remote tools. In line with that, today's event and this year's IISF is going to be held virtually, and today's curtain raiser function is organized now by CSIR SCRC. I request our director, Professor Santosh Kapuria, to start this event with his welcome address.
Thank you, Bharti. So, Dr. Annadurai, Vice President, Tamil Nadu State Council for Science and Technology, Dr. Shekhar Mande, Director General CSIR and Secretary DSIR, Dr. Purnima Jalihal, Director NIOT, and my dear colleagues of CSIR SCRC and CSIR Madras Complex, and today all those who have joined today through MS Team and YouTube and other social media platform, Facebook. A very good afternoon to all of you. And this is my proud privilege to welcome you all to this curtain raiser function for the Indian International Science Festival 2020, which will be held from 22nd to 25th of December 2020. You know, very aptly, this festival, this name is festival. So essentially, we celebrate science as a festival in India. I think never before this such a name has been coined for a science-based thing. It's a wonderful name, and that shows the spirit in which we need to celebrate this. And I'm really glad to recall today that the first event, IISF, started in 2015, and it was held in IIT Delhi when I was in IIT Delhi, and I was, involved in that. And the very next year, it was organized by CSIR when I came to CSIR. So, I brought IISF along with me, and it was done in Delhi again, but by NPL. And then the third one was actually in Chennai. I was in Chennai that time, and we are part of the, this Anna University, IIT Madras, along with CLRI and SCRC, along with NIOT. Of course, NIOT was the main fulcrum. Dr. Purnima is there, and we all worked together at that time. So I'm so fortunate that somehow this program I have been associated for the first 3 versions very deeply. We also had some program that time. I remember here in SCRC, and I think our DG was present in that program, which of course I didn't know about it. So that is the history. So I have some kind of attachment to this. And then again, after 2 years gap, we are again, CSR is sort of organizing it, nodal as a nodal agency. And this is being done by NISTAR, of course, this time, but whole CSR is backing it. And it is such a good feeling that we hold these, and I have seen in my own eyes that how the children, particularly the young researchers, the young scientists, they all over the country, they come and they really, really enjoy the spirit of, the science and technology. The whole idea is to not only celebrate science, but also bring in the scientific temper to the young minds of the country. The real, science is something, particularly those children who are joining today. I just like to say that science is something, it is possibly the only thing which always tries to self-disprove itself. All the time, if there is a postulation, theory, theorem, whatever, there will be some people always working to test that whether it is really, true under all circumstances. Always tries to disprove itself. So that is the strength of science. It is not a dogma at any point of time. And that is the questioning spirit that I think we need to all inculcate among ourselves. And our teachers used to tell us, I remember, that even if something is written in a book or a paper, doesn't mean that you have to believe it in without questioning. Everything, your mind should be open, and you must, with an open mind, you should address each and everything that comes in front of you. So with this, I think I welcome you again all. This is my privilege, and I would like to request that all the children, there are so many schools that I'm trying to connect. I'm not sure how many are attending, but if you are listening to me, I think please make sure that this time it is going to be through the virtual platform, so you don't have to travel, all the way to the venue. So all virtual, and it will be made accessible. So please register and do participate in this the great event which are going to come, during December 22nd to 25th. today we have, of course, we are very fortunate to have our DG himself. He's such a beloved Director General. We all love him actually, all the directors, all the scientists, all the staff. And so he is always encouraging. So he will be there, leading from the front. He has both the styles. Of course, I'll tell in some other platform, not today. So yeah, so he is there, and then we also are fortunate to have, of course, Dr. Annadurai, who is an excellent orator and inspiring, scientist, children and young researchers and scientists. They relate to him, particularly in this region, very well. So I'm sure we'll be, gaining from his participation. As a curtain raiser ceremony, it will be a very great contribution. And then Dr. Purnima Jalial, I know that in the last time when it was held in Chennai, how much you were involved, so you know the nitty-gritty of it. So therefore, your presence today is going to make another extremely high value addition. So with this remarks, I once again welcome you, and I now look forward to your talks now. Thank you very much.
Thank you so much, sir. The challenge of hosting this year's IISF has been undertaken by CSIR, and everyone in CSIR family is on the mission to make this program a grand success under the able leadership of our DG, Dr. Shekhar Mande. I now request him to deliver his presidential address. Sir.
Thank you, Bharti. Bharti, I think you went mute just when you were saying something, but I hope you are able to hear me. Dr. Annadurai, Dr. Purnima, my good friend Santosh, all the members of CSIR SERC family, and all those who have joined us on this virtual platform today. It's my pleasure to be with you on this particular occasion on the curtain raiser event that is being held at SERC Chennai. Just to give you a brief background, about 6 years ago, Dr. Harshvardhan floated an idea that we should celebrate achievements of scientists of India amongst general people. The idea was not only achievements of science, but also prominently display the work that is being done in India and so on and so forth. To give a view to the public that a lot of good things that are happening around us in science and technology within India, and people must be aware of that. And in 2015, with this particular view, the first of its kind festival was held on IIT Delhi campus, as Santosh mentioned. The next year was in NPL Delhi once again, which CSIR was the host. Next year, as Santosh mentioned, we went to Chennai, then to Lucknow, and last year we were in Calcutta. So this is the sixth in series of the science festivals. This is going to be held between 22nd and 25th December. There is symbolic, these two dates that we have chosen. 22nd December is the birth anniversary of Srinivasa Ramanujan. All of us know, the Chennai people should know it even more. He worked at Madras Port Trust for a while before he actually became very famous. And 25th December is the birth anniversary of our former beloved Prime Minister, Shri Atal Bihari Vajpayee ji. And all of you recall that when the slogan was very famous, Jai Jawan, Jai Kisan, Shri Atal Bihari Vajpayee added Jai Vigyan to that. So essentially to also celebrate to some extent some science. And therefore these two symbolic dates have been chosen between 22nd and 25th December. This is being held by Ministry of Science and Technology, Ministry of Earth Sciences, and the Ministry of Health and Family Welfare together in collaboration with Vigyan Bharti. Many of you know that Vigyan Bharti is a very large social movement which tries to bring the achievements of Indian scientists to the general public, and more with a Swadeshi spirit. The Swadeshi spirit because people should know the achievements and the kind of work that Indian scientists do. And all of you are aware that how much work that actually is being done in India and how much value it has brought to Indian society. Just to give you an example, the recent cyclones that came in that all of you also witnessed, their predictions were so accurately made by IMD, Ministry of Earth Sciences, that the extent of damage that we could have imagined happening about 20 years ago, that has been greatly reduced. that extent of damage that is done to human lives, to property and things like that. So all agencies put together, whether the ISRO, where they actually develop very high resolution imaging techniques, whether IMD, who have actually developed very good prediction techniques, and the administration together. So everyone working together actually has brought benefit at least of the predictions of weather. But there's only one example. There are many such examples. And during the COVID time, many of these examples have also been brought forward by CSIR. You would have heard of CSIR's achievements during COVID times. Things like the Feluda diagnostic kit that will hit the market in a day or two. The BiPAP ventilator that also is hit the market now, or the ready-to-make hospitals, in which SCRC Chennai played a very important role in ready deployable hospitals, and so on and so forth. So scientists actually are working relentlessly for the betterment of society, and we should all be very proud of that. And we must bring these achievements to the society. The society must know that how much science and technology is happening for their own benefit. So I'm very glad that all of you are here who have joined for this particular event, curtain raiser event, and we will celebrate all of this in about 41 different events during IISF 2020. And I look forward to all of you joining that. I look forward to all your friends, all your family, everyone to join in celebrating this particular festival, and wish you all the best for today's function. Thank you.
Thank you, sir. Thank you so much for the inspiring words. It is my pleasure to introduce our guest of honor, Dr. Purnima Jalihal, to the audience. Dr. Purnima, a PhD holder in civil engineering from Duke University, is at present the Director of National Institute of Ocean Technology, India. She has coordinated many first-ever projects in ocean energy and desalination, including the technology for the wave energy-powered navigational buoy for use in ports, the marine hydrokinetic turbine, the first-ever wave-powered desalination system. Currently, a large-scale desalination plant at Tuticorin Thermal Power Station and an OTEC-powered desalination plant in Lakshadweep are on the anvil. She has done tremendous contribution in setting up the first ever ocean thermal gradient-based desalination plant at Lakshadweep Group in the Arabian Sea, which has helped transform the lives of small island community. For this work, she was awarded the Vishwakarma Medal in 2006 by the Indian National Science Academy. She is on the many committees of Indian government organizations related to water and renewable energy. She represents India in the International Forum of Ocean Energy Systems Technology Collaboration Program of the International Energy Agency. She is also the chairperson of the Indian Desalination Association South Zone. She was awarded the Uhura Prize for the year 2019 by the International OTEC community for her contribution to the development of ocean thermal energy conversion. She is the EU-led Clean Energy Mission Innovation Champion for India in the year 2020. With this very brief introduction, I now invite Dr. Purnima Jalihal ma'am to deliver her address. Ma'am.
Yeah. Thank you very much. Can I share the PPT, the PowerPoint, please?
Sure, ma'am.
Share. I'll control. A very good afternoon. Just make it full screen. A very good afternoon to everybody. Thank you to Dr. Kapuria for inviting me for this very special event. And my warm regards to DGCSIR and also our chief guest. This is a really great opportunity for me. As Dr. Kapuria said, I have been associated with the IISF completely when it was done by NIOT, and we of course always have been participating in some way or the other in all these years. This year, in fact, the Ministry of Earth Sciences is coordinating the air and the water segment, and strangely enough, we had the curtain raiser for the water segment today morning. So I'm really happy to be part of this event, which is a curtain raiser for this festival. And what I thought I would do is, ocean technology is less known in the country, and this is a really excellent opportunity for me to talk a little bit about it today, so that scientists, young researchers and students, if any, would all be able to understand what goes on in the country, because a lot of it is not completely known. So I've called my talk Ocean Technology for a Self-Reliant India, because a lot of work that we do here in NIOT is indigenous, and that should prove a motivating factor for young researchers. So this is a very simplistic picture. It looks like it is taken from a standard 7th or 8th standard textbook, but it carries a lot of meaning, because atmosphere, ocean, and the earth, they're all very, very interlinked, and that's why the Ministry of Earth Sciences is so important, because all these facets are covered under this ministry. And there's
a slide is not moving, madam. Yeah, fine.
Yes.
Yeah. Yes, madam. Correct.
See this
okay.
now?
Yeah, fine.
Yeah, sorry about that. So basically the interlinkages between the atmosphere, ocean, and earth are many. They're very complex, and all these are still yet to be understood, and especially about the ocean, there's a lot that is still unknown. But it is true that the atmospheric effects on the ocean, or the landmass and its influence on the ocean, or the movement of the tectonic plates, all these have a role in what the ocean and the atmosphere and the land do today. And these are all important from the perspective of understanding or developing technologies. So under the ocean sciences broadly, all these come into picture. That is biology, chemistry, physics, geology. All these play a very, very important role. For instance, these are marine biological specimens. We wouldn't even have known that these kind of organisms exist at a depth of 1 kilometer. And this has been actually photographed by our own remotely operable vehicle when it went down to more than 1,000 meters water depth. So this is like, there is a lot of unknown biology still, which we are still trying to look for. There's a lot of physics associated with the ocean, because we know that the only way to transmit any signals is through acoustic waves. And therefore, physics plays a very important role in understanding what lies below us and what is not visible to the naked eye. We have a huge chemistry that we need to worry about. And of course, the very components or the constituents of seawater makes it what it is. And for us, when we look at seawater for fresh water, this proves a real challenge. Now we come to the oceanography. Largely, we talk about waves, winds, currents, tides, and temperature. And these are all, to a large extent, understood because of a lot of advancements in the field of oceanography. However, going across and trying to, sort of mitigate them or deal with them is not easy at all. You would have seen waves at the beach, but this kind of breaking waves look very beautiful from far. But for an engineering solution, they are quite a disaster. And the designs or the analysis that is required, or the R&D that goes into fathoming how to deal with these kind of waves is quite a difficult and challenging task. Of course, waves are random, and even a normal wave, which is not a breaking wave, these have to be defined by spectra and things like that. I won't go into all these kind of issues. I'm just trying to sort of bring a spark of interest into a young researcher who is not familiar with the oceans. The oceans also have a temperature profile, which many people are not really aware of. And the warm surface sea waters, as you go down, the water becomes colder. This, in fact, is the phenomenon that we have been using in our thermal desalination technology. So this is also something which is many times not known to a lay person. So these are the opportunities we get to sort of make people understand some of the issues that are not known about the ocean. Now let's come to the Indian scenario. So what I was trying to say earlier is all this is sort of required to be understood about the ocean when you want to try to design things for the ocean. So now we talk about India and why it is important for us. So we have a long coastline, anywhere between 7,000 to 8,000 kilometers approximately. We have a large exclusive economic zone, which is shown by the hashed area. And because of the Lakshadweep Islands in the Arabian Sea and the Andaman Nicobar Islands in the Bay of Bengal, we have a fairly large EEZ. So EEZ belongs to each country, and for us, we are blessed with a long coastline and a large EEZ. Also, 30% of our extremely large population also lives along the coast, and therefore it makes all the more it is more prudent, therefore, to really understand and go the way of ocean technologies, because it is going to cater to a very, very large population. Having said that, just briefly, and we are the only ocean technology institute in the entire country. People confuse us with NIO, which is a CSIR lab, but they are into oceanography and sciences, and we are the technology developers. So broadly, we have 4 or 5 large areas. One is energy and water, which I look after. There's offshore structures, there is deep sea technologies. We have a coastal and environmental engineering group, which does a lot of work with coastal protection and shoreline management. Smaller groups like acoustics, electronics, sensors. We have a biology group, and we have our own infrastructure, which I will show you later. And we also have basically the data buoys, which DGCSR was talking about the predictions this time. So I'll tell you about that in a little while. So as far as ocean technology goes and what NIOT is working on, we divide our work into 4 thrust areas: resources, niche technologies, services to society, and infrastructure. So essentially, resources is something that the ocean has plentiful. The only challenge is, how do we harness them? I won't use the word exploit. I'll use the word harness. How do we harness it so that we make it environmentally friendly as well as clean? Niche technologies are technologies that need to be developed not only for like societal purposes, but really for strategic purposes, especially with the neighboring countries. So niche technologies are important for those. Services to society, and then the infrastructure. So I'll first talk about the resources. So as was told in the introduction, I have been working on ocean energy and desalination for the last couple of decades. And still these are very, very less understood. We are the only institute which is working on actually developing prototypes, testing them at sea, and then trying to scale up. There is some small work going on in the IITs, but it is very, very just at the modeling and theoretical stage. So, but we have had our successes and failures, and today we have at least developed, on the way to scaling up, we have developed a product which is going to be useful for ports and harbors. There are a lot of small remote islands, especially in Andaman and Nicobar, which is actually a security kind of a zone, and they have forest outposts where the people or the security guards are sitting without energy or water. For such places, off-grid small units of these kind of renewable energies are really, really useful. And so we are trying to, now we have an MOU with Andaman administration, and we are going to make some of the wave-powered navigational buoys and the hydrokinetic turbines for them. We also work on ocean thermal energy, or OTEC, which actually got slightly diversified into desalination, and I will come to that shortly. So as far as ocean energy goes, those are the 3 forms that we have been working on. For water, this is a very typical picture which is shown when we talk about how much fresh water is available. So we have Earth, which has got more than 71% of water, but out of that, the fresh water available is only 2.5%. And though I won't go into the nitty-gritties of what actually is, why we are doing this, suffice it to say that the water stress is very well known in the country. There is a need for new technologies. There is the need to augment water. Of course, people will talk about conservation. Conservation has to be done. It has a large role, and it needs to be done. However, conservation and management of water resources while they do play an important role, the large requirement that is now coming up in the country is really going to be met with only by augmenting water sources. So one of the methods is to have wastewater treatment, which many domestic gated communities and all are now trying to get into, which is fine. However, when you want very, very large quantities of water, especially for remote islands as well as metro cities, looks like now desalination is an important way to go. So we have actually, everybody knows about reverse osmosis, which is being done in, especially Tamil Nadu has got several reverse osmosis plants now. And there are issues with reverse osmosis, which this is not the forum for me to go into those. I'm just trying to tell you which are the technologies which we have developed, which are like indigenous and which are, are really exciting. So we wanted to do some technology, we want to demonstrate which is clean, environmentally friendly and completely indigenous. So we chose this island called Kavaratti, and this is in the Lakshadweep group. Today we have this first ever desalination plant there, and this is of course just the finalized product, but we had the most complex and challenges to face there. And the important configuration that this plant has is that it has a long pipeline which is held only at 2 points, and you can see in the top left corner picture the 2 lines which go down. So this is the challenge of this project, and this was what NIOT did successfully. The right hand side pictures show the actual pipeline. It is made of high density polyethylene, it's called HDPE. And this was actually deployed by very small boats and a barge. Now, why I'm talking about this? While it is true that we have done a whole lot of work in this, the takeoff from here for a self-reliant India, in the year 2000, when we were trying to work on an OTEC project, we had to actually import HDPE pipes from Malaysia and Thailand, because I was the one who had actually raised the indent for those pipes and got them welded at the field at Tuticorin. The year 2004, when we started the design of this product, we were just not wanting to get any imported pipes. This was made in India in a small company called Nosil in Maharashtra, in Akola, and they were actually just suppliers. We actually taught them how to weld these pipes, and this pipe, I'm very happy to tell you that in all these 15 years, it has still withstood, it is still pumping cold water, and it is still giving fresh water to the island. It is a very big achievement for us. It has even withstood the Oki cyclone, which devastated all the islands in Lakshadweep. So, this is a completely indigenous pipeline with Indian raw material. So from then, from the year 2005, today in India, there are several companies which make large diameter HDPE pipes, and we don't have to import anything anymore. So, I mean, we have to start towards self-reliance, and these are some of the projects which go a long way in kind of enforcing and understanding that, these things can be done in India and these things are being done. So, of course, the fresh water is continuously still being distributed even after 15 years the plant is working. So, as an engineering achievement for societal benefit, this has really made us very proud. Subsequently, we have done several projects using the same technology. We have more plants in the islands and we have scaled up. We have shown it in power plants. We have tried to use renewable energies where we did a solar multi-effect distillation system. So coming to, when I say solar and renewable energy, the main component which goes into any desalination system, whether it is membrane or whether it is thermal desalination, energy is an important component. And this is what makes desalination very expensive, because of the requirement of energy to drive either the membranes or the thermal component system. And to this end, we have always, it's been very close to my heart that we should always have hybrid systems. So in the way back in 2003, we had a wave energy project in Kerala, which we have now decommissioned because it was an R&D kind of a project. We got the energy from the waves and we ran a seawater RO plant in those days. And it was the first ever plant which was a wave powered desalination system. And in fact, for several years, the local fishing community was using that water. We have decommissioned it now. So this is the solar desalination project, which is a DST funded project. DST and NIOT jointly, along with an industry, we developed this at Naripayur near Ramnathpuram. So going forward again into the self-powered desalination. Now all the island projects, they are using diesel generators for their energy requirement because the islands have only a diesel grid of 1 megawatt and 2 megawatts because the populations are very small, about 10,000 people per island. So as it is a big problem for transporting diesel from the mainland to these small islands. 4 months during the southwest monsoon, there is no way this diesel can be transported. So it is like, you know, every small ml of diesel matters. Secondly, diesel is, as you all know, very polluting, and these are very pristine coral islands which have to be preserved and kept pristine. So towards this now we are embarking on using power from the ocean thermal gradient, where the power comes from the thermal gradient, the water also comes from the thermal gradient. So it's a neutral self-powered system where no energy will be drawn from the grid at all. And to do this, we have set up a laboratory here. We have the first time, I mean, I don't think anybody has done it on this proper scale. It is not like a huge amount of water or power, but we can run all the cycles, and we have actually learned a lot from this plant in the NIOT laboratory itself. And we can now run any kind of open or closed or a hybrid system with or without OTEC and only desalination. So we have developed the expertise now to design the turbine, which is the heart of this system. And with this experience now, we have designed an OTEC powered desalination plant for the same island of Kavrathi. So there will be no power really pumped to the grid in this first ever project. So we will have only enough power to make it self-powered. There are several challenges here. While the basic desalination part remains the same, the power generating unit or the power module, the turbine and generator unit is being done for the first time ever. So we have to design, we have to actually make the power happen and not draw power from the grid. It is a very big challenge. We're also operating with a very small temperature difference. So it is also a big challenge. There will also be another challenge when all these pipes we have designed so far are only 1 kilometer long. This project is going to have a pipe nearly 4 kilometers long because we need to draw water about 8 degrees Celsius from the about 1,000 meter water depth. So this pipeline, the design, its installation is a very, very challenging and complex activity. And we are like all set to do this. In fact, the designs are ready and the RFPs and everything are going on currently in full swing. Now I continue with energy. NIOT also does energy from algae. Basically, there is a lot of work done on biofuels and biodiesels by CSIR labs for biomass as such. But energy from algae is an important thing that should be taken up, and we have been demonstrating and doing a lot of experiments in NIOT. In fact, we did prepare a B10 biodiesel using the lipid extracted from the Chlorella vulgaris, and this was actually, in fact, we have I don't know, I don't think I have the picture of that, but we have actually demonstrated it by driving an NIOT vehicle using the B10 biodiesel prepared. Now, so far we were talking about energy and water. So I also will talk about food from the ocean. So NIOT is involved in the designing and development of open sea cages where we actually grow the larvae in cages in like a small protected area where they grow, and then they can be harvested, and then they can, be of commercial value. These require some kind of designs because, there is a mooring, they have to withstand storms. Right now, NIOT is also working in something a more automated cage, wherein in the case of storm, we should be able to lower the cage completely, keep it safe, and bring it back again. So those are the kind of technological developments that, sort of make indigenous small industry and commercial, welfare of the coastal population. So this kind of open sea cage culture, we have actually taught or transferred the technology to lot of fishermen in various places like Olekuda and Kottachatram in Tamil Nadu. And in fact, women's groups have learned and taken over this technology, and they are actually making profit, and they are very, very happy. So this is again where, we have developed the technology. This is for food, and this has also gone down to the masses actually. So the design of these is what, the technology development is, we know that you can breed fish if you give a protected environment, but the protected environment, if it is in the ocean, the breed is, they breed better and faster, and, that's what technology can achieve. We have also actually made artificial reefs in places like Orissa. See, what happens is whenever you have some kind of unit or a system or some kind of, let us say, a small, even a piece of stone or something that sits for a long time in the ocean, small algae start growing, small organisms come around it, then the big fish start coming, the bigger fish come to eat them. So this becomes like a fish aggregating device sort of. So these kind of artificial reefs we have actually made in Orissa. This was funded by the UNDP, but it was implemented by us. And now these artificial reef deployments have led to huge fish catch, and this also has helped the local population very much, the coastal fishing community. So we have talked about food, energy, and water from the ocean and the technology developments for those. Now we come to niche technologies where we are, like I said, we're trying to harness minerals from the ocean. These are available in deep water, something like 5,000 to 6,000 meters. So there are polymetallic nodules, hydrothermal sulfides, and gas hydrates. And this is a very, very complex kind of technology to develop, because as you go deeper, as you all know, the pressure is very high. You need to develop special pressure casings. You need to be able to deploy these equipment from on board the vessel. It's all being done in the blind sort of, because the vehicle has to move on its own below. And so the signals, the umbilicals, the ratings of all the materials and structural and mechanical rigidity, strength, all those are very, very challenging. Additionally, the soil is quite soft at the bottom, so the design of the crawler system itself is tough. So this is being implemented right now. We have come a long way, and we are now towards the latter part of the design so that it can be put together for deployment. The biggest challenge that NIOT has taken up today is the design of the manned submersible. We have an unmanned underwater vehicle already that we are good at. That is the ROV, the remotely operable vehicle, which is being seen in the top right-hand corner here. That is the one which had taken the pictures of the organisms which I showed you earlier. This needs an umbilical, and it doesn't have people on it. It is unmanned, and it goes, takes pictures. It's a world-class ROV. It has helped in actually DRDO's torpedo search and things like that. However, the big challenge now is to send 3 men down, and for that, you can understand when it goes to 6,000 meters with 3 men, it has to be, or 3 persons, I would say, it has to be a very, very perfect design, because there is human safety at stake. So we are calling this a Matsya 6000, and we are going to do the Samudrayan by 2024. So this is completely, in fact, we had tried to get the entire unit by a couple of RFPs, which did not work out. So right now, NIOT is actually buying all the things separately, and we are going to put it together, we are going to test it, and we are going to probably also get trained to go underneath. So this will be a really very, very big achievement. I'm sure this is very exciting for young researchers and students, just like Chandrayaan in space. This is Samudrayaan in 6,000 meter water depth. So right now, NIOT's two big challenging projects which the ministry has its eyes on are the OTEC powered desalination project and this manned submersible, which has got several challenges. We also do a little bit of work on gas hydrates, but we do only the technology development. We're really not into exploration and things like that. For this, we have developed an autonomous coring system because the Krishna Godavari basin has gas hydrates, and the coring system is supposed to go and pick up cores to find out where and how much of gas hydrate is available. Now we come to societal programs. These were the technology developments. Now we also do work which actually specifically helps the society, though of course energy, food, water had a dual role. It has a lot of technology development and it's also societal. But here this is a slightly different kind of a work. A lot of beach restoration has been done by NIOT, Puducherry, Kadlur Periyakupam. A lot of sea erosion has been happening, and there is no way the beach can be restored. A lot of beach is just getting eaten away. So a lot of modeling is done, and then we have actually implemented in these two places such that the beach has got restored. The Puducherry one has been a success, and so has also been the Kadlur Periyakupam. The technologies used were different, but both have proved themselves well. So it of course depends on the site and the location and the actual conditions there. And these are something which have really benefited the nearby communities which had lost their beach and the coast completely. We also have this, which is the main, we are the link to IMD actually. We have these data buoys all around the Indian coast in shallow waters and deep waters. Now this data comes through satellite to our shore station here in the NIOT campus. It is given to our sister institute INCOIS in Hyderabad, which does all the data analysis. It is further given to IMD for the prediction. All the recent cyclones which have been, which we have witnessed, have been actually captured with our data buoys. Even as the last cyclone, we were also, this has been captured and IMD predicted it so well. These data actually go into the models where MOES institutes like NCMR, WF, IITM and IMD all work towards improving the models, and this data goes into those models to improve the weather prediction of the country. I think now I'll come to the last couple of slides. My time is getting over. We also have a set of HF radars which measure surface currents. So these are all helpful in mitigation. I mean, like when you have cyclones, the prediction and understanding and ensuring that people move from those areas, all these really have been helpful in all these situations. We have, this is again technology development, drifting buoy with INSAT communication. The biggest thing is measurement of noise. We have a group which works on acoustics, and we measure ambient noise systems. We have ambient noise systems which we are developing, and this has been used even in the polar region for measurements. Lastly, I come to infrastructure. We have our own vessels. We have one big vessel called Sagar Nidhi, which is a DP class 2 vessel. That means it has dynamic positioning. We have Sagar Manjusha, which is a medium-sized vessel. We had two earlier vessels which have been now decommissioned, and we have built two new vessels recently. Both were commissioned last year. One is Sagar Tara and one is Sagar Anveshika. These are the vessels which we use for all our technology demonstrations, and we also, all of us sail, all in NIOT. I would like to say this emphatically to encourage and make youngsters excited about sailing and doing the deployments ourselves. Everything that we try to do ourselves within the country with Indian, staff and scientists. We also develop many of the things indigenously. So these are our own vessels, and then we also have other infrastructure like a hyperbaric chamber and an acoustic facility. We have a lot of infrastructure already in the institute as well. So I hope this has been an interesting talk for youngsters and making the people come to know what NIOT is all about. Once again, I thank all of you for this opportunity, and anyone who wishes to see, you're most welcome to come and visit NIOT as well. Thank you very much.
Thank you, ma'am. Thank you so much for introducing us to the science and technology being carried out in the magnanimous ocean body, and also how relevant it is towards achieving self-reliance of our society. You are truly an inspiration to all the women in STEM. Thank you so much, ma'am. I feel privileged and humbled to introduce the chief guest of today's function, Dr. Mailswamy Annadurai, to the audience. Dr. M. Annadurai is a renowned space scientist of international repute and technical leader of par excellence, currently holding the responsibilities of Vice President, Tamil Nadu State Council for Science and Technology, and Chairman, Board of Governors, National Design and Research Forum. With the educational qualifications of BE, ME, and PhD in engineering, Dr. Annadurai joined at ISRO in 1982 and grew to lead more than 2,500 strong scientists and engineers as Director, ISRO Satellite Center during the year 2015 to 2018. As Director, ISRO Satellite Center and Chairman, Program Management Council for Space Infrastructure, Dr. Annadurai played a pivotal role in expanding ISRO's horizon. He guided his team to realize a record number of 29 satellites as on June 2018, enabling the center's capacity to make about 18 satellites per year from the year 2018. Two of the most significant achievements of ISRO, namely Chandrayaan-1 and Mars Orbiter mission, were led by him in the capacity of Project Director and Program Director for the respective missions. He had led many international committees on space sciences and contributed immensely to the space research, so much so that his education and achievement in satellite technology have been highlighted in 10th standard science textbook in Tamil Nadu curriculum. He is also a perfect example of socially conscious scientist, finding time to always inspire young generation through his books and by delivering various convocational addresses, keynote addresses. Dr. Annadurai has received very many recognitions and various national and international from various national and international bodies, including the coveted Padma Shri Award in 2016 for Science and Technology from Government of India. Since 2019, Dr. Annadurai is working as Vice President for Tamil Nadu State Council for Science and Technology, a new position created by Government of Tamil Nadu with the mandate to strengthen the development of S&T in the state. Recently, he has been also appointed as Chairman, Board of Governors, National Design and Research Forum by Institution of Engineers, India. Sir, we are so honored here today that you could join with us and eager to hear your address. May I now request you to deliver your address, sir.
Thank you. Thank you very much for the very good intro. Dr. Sagar C. Munde, Director General CSIR, Professor Santosh Kapuria, Director SCRC, and today's guest of honor, Dr. Purnima Jalihal, Director NIOT, and other guests, possible good number of students. Today being the curtain raiser for this science festival, India International Science Festival, with the theme Science for Self-Reliant India and the Global Welfare. We have seen the depth of ocean, what we have seen in the previous presentation. I also would like to make, but this is not going, not go to the depth. Considering this a curtain raiser, I am going in a breadth. That means from ocean to the space, depth of the ocean to the limit of the space. India has good number of opportunities. India has done it, and India is poised to make it, and science and technology will enable. So what's the type of opportunities available and what we can do? I think that's a thing I think I'm trying to touch upon next 35 to 40 minutes. My view graph, please, Ashok Kumar. Yeah, that means science for self-reliant India and global welfare. Though we talk about a topic like this, as rightly told, the STEM. That means science and technology for self-reliant India and global welfare. That's what I'm going to touch upon. Next, please. Now you look at here historically. Historically, now I think you know the students are there. I'm take more like a story. Science and technology is the one basically enabled the differentiated from other animal how the human got evolved. And birth, life, and death is almost common for the life form. But what made the thing is humanity got evolved because of the inquisitive of questioning. But was love the science. And it not everyone has questioned it, few of the scientists enabled it. But the festival like this, when we are seeing, we are trying to see what the people have achieved, what the systems have achieved, what the teams have achieved. So this is nominally useful. Reading the history or going through the history is not only just a spectator, you also can make a history. Some people can do that. So that means knowing versus being a part of in the future definitely will enable. That means the scientific festival is whomever today observing as a spectator going to be tomorrow's performer in the future. I think that is the more objective of that. The curtain raiser is how you can bring the people inside. So that way you look at like any other animal was there, but now I think man has evolved to a level and looking for one side the depth of the ocean, other side he is trying to see the limit of the space. And this is the science and technology is evolved. Next, please. Yeah. Now, as I told previously, symbolically I'm trying to put that inspire and get involved. Yes, somebody sees the train is going, so he is spectator. Like today's festival, if you see, somebody will leave like that. But someone is part of that system also. Part of the system also. He enjoys, he travels, he make a journey along that. So like that, the idea here is along when the festival, the thing is happening, is trying to enthusiast the people, trigger the people, inspire the people to get along this journey of lifelong journey into science and technology. Today's condition, Indian point of view. Next, please. Yeah. Now, when I'm talking about science and engineering, this is I've taken as a popular lecture. So the nominally we used to tell the scientists discover what's already there. Black hole was already there, and the science feels happy of discovering it. But engineer makes what is not there. iPhone was not existing, but engineer is the one who made it. That's how we will try to collect it. But putting the things together, both science and technology is really required for the humanity. That means scientist looks for a new world, whereas engineer makes the world livable. I think this is the combination. Both are required, but just to give some sort of a flavor of what is science and engineering point of view, this I am trying to put it here. Next, please. Yeah. Now coming to the phase of what we talk about self-reliant. Self-reliant basically it comes under the 5 pillars of self-reliant India: economy, infrastructure, system, demography, and demand. This is the 5 pillars in which even nearly 10% of GDP is being allotted to raise these pillars in terms of infrastructure, system, various demographies in the largest demographies, how it can distribute, and that's the happening there. But the base of that 5 pillars, the basement of the 5 pillars, I feel it's a technology. Technology to be innovative, to be self-reliant. So that should be the major thing. So then only all the things will come. Again, the technology should be innovative. That means innovation has to sustain. That innovation to sustain, it should be innovation-driven development strategy. I am trying to touch upon what does that mean. Next, please. Yeah. Again, yeah, you can go back. Yeah, no problem. Yeah. Yeah, now you look at here, just I'm trying to touch upon. That means whatever I shown previously, science versus this, innovation versus invention and discoveries, the same example. You look down, it looks like invention discoveries, money is spent to find something new. Even the black hole, to take this first picture, maybe it's simple, but still to make that millions of money was spent. and thousands of manpower, intellectual manpower are used. But you look at here, innovation, money is made by putting together what already has been invented. I found many things, convergence of many things putting together, whether the touch screen or the connectivity or whatever we are talking about is the basically convergence of many existing technology as on that way, packaging the things together. That means innovation is not invention, but it's about putting the available technology into better use to create value addition, to the business and social impact. Another thing is it should have social impact. Whatever we do, all this science and technology and this, it should have a social impact. Then only it will sustain. That's right. Next, please. Yeah, just I'm giving some few example when we're talking about, I think good number of students may be there in the social media. I'm trying to touch upon what does that mean? Just give a few example. That means now various reasons. For example, when we're talking about aerospace or in ocean, wherever it is, we will be looking for some special materials may be called for. But that material may work for some other environment. For example, in acid environment, some specimen has to work. To test their compatibility, a simple problem, test a compatibility. What you see is the one idea is put the specimen and put into a tub, in that pour the acid and check for it. After 1 week or 10 days or 1 month, this you see how much, whether the specimen has any issue or not. But they may look simple, but you look at what right side says is, probably the specimen would have survived, but what would have happened is specimen that the bathtub, if it are not clear about the bathtub is compatible or not, that would have created a problem. That means that means your problem is acid and specimen compatibility. Now we are supposed to have seen another domain of that bathtub, whatever made the material also, whether it is compatible or not, which are question. But you look at same problem attacked in slightly different way, idea too. That is innovation within the existing domain. You have to see about, which specimen it works, and you put the specimen, cut the specimen, and pour the acid inside. As simple as that. Other than these two material, nothing is there. It is as simple as that. This is called innovation. Even for something to test, you need innovative way of thinking. This is what I'm trying to put. Next, please. Yeah, is another thing. Another thing, probably some innovation would have been there. Your product has been come. I'm trying to tell how it should have a relevance and social impact. You could have done everything. For example, this is tomato ketchup. Tomato ketchup instead of only one color. Why can't it be multicolor? A good amount of work has been done. But finally, when the product came to market, nobody was ready to take other than the red ketchup. Okay, the problem is people somehow they didn't like it. This is what really happened. So this is one side, even though it's a new novelty, everything may be okay, but still acceptability in the society also called for. Acceptability end user also called for. This is also really required. The innovation includes end to end. Next example, yeah, is another thing. This is you look at here for the dog. When we are trying to get it's suitable, okay, it's food point of view. The dogs also have their own problem in their bone, other things point of view you are there. When you are making the food, when we are this being work, this coming as a pet in the house, you have to feed them. When you are feeding, when you are trying to go yes, but that is also a big market. But when somebody else came out with an idea, very nice eatable, but it has every nutrients are there. But unfortunately, as the figure shows, the dog was ready to eat. The smell was not good enough for it to eat. Okay, but that means this end user is not liking this to happen. So that also to be taken care. Next, please. Height of all the things. Okay, in the whole thing you look at here, the idea of Tata Nano, you know that. I think it's one of the good technological thing happened. Just replacing almost the same cost of a two-wheeler. 4 or 5 people of Indian family can go in a nano car. It's one of the very innovative thing. But next, please. It failed. It failed. It could not get into that. Tata himself has told, Ratan Tata himself has admitted the mistake. What is that? It is not engineering mistake. It is the way in which you advertised. It's a poor man's vehicle has been advertised. And no Indian was ready to take a vehicle, a car, he buys beyond his travel, other thing, he buys it for a status symbol. But nobody wants to buy a car and drive or keep it in front of house and declare himself as a poor man. I think as simple as that. And this afterwards, whatever they did, I think they could not come back. I think the whole project collapsed it. So this is another example of end-to-end seeing, end-to-end looking for is called for innovation beyond the technology, beyond the science. I think that's also called for. This is also a science. It's basically a human science is also called about. Next, please. Yeah, that means putting the everything together, I'm trying to tell. That means whatever you innovate, it may be innovation, it may have research, it may have technology, it may have economy also. Nano car is an economy also. But research, technology, economy alone is not enough. Lesson learned is innovation supposed to have research, technology, economy, and impact and social development. I think that's also here. What impact it makes, whomever receives, what impact it makes, and what is social development. That is also equally, not only equally, that's very much required there. That means sustainable social transformation and development. When you are looking for that, the innovation needs to be redefined like this. It's to be beyond an innovative item, having a technology convergence, having a business sitting there, but still without impact and social relevance, I think the whole thing will not survive. I think that is as simple as that. Any innovation we can consider. So that way, a self-reliant India to have its presence felt within India as well as a global, this is the parameter I think we should consider. Next, please. Yeah, that means putting together technology may give an opportunity in business. That data nano is one of the file thing because 1.2 lakhs is a very good business model existing. Technology also existing. But what value it has given to society? That feedback only gives the consensus of private. That's what I'm trying to put. But all the examples I showed here, this is having. That means there is a fine interplay between the above three: technology, business, and society. That means innovation is a key to the future, no doubt. But basic research is the key to the future innovation. That is end-to-end. That end-to-end is called for. It should have technology, it should have business, it should have societal relevance. Technology may be there, societal relevance may be there. If business is not there, also it cannot sustain. That is also another equally you have to consider. That means technology, business, society is the very interplay between the three things are there. When the pillars of innovation is concerned, we thought initially the pillars of our self-reliant point of view, the pillars. Now the pillars of innovation itself, I would like to define like this. Next, please. Yeah. Now coming to the satellite, the innovation is already happening. Okay. Now cell phone. Okay, it made a big innovation. It made a very good inroads, and it's one of the big innovation which enabled the people to connect. After the internet, definitely cell phones made, and the convergence in the cell phones made many things to happen. But now the limitation of the cell phones being relying on the cell phone towers, now it's being taken now by the satellites, and the satellites. Now we look at here. This view graph talks about given time. Revolving satellites around the Earth, any given time, minimum 5 or 6 satellites for any point can be seen. That means that many cell phone towers are there, anybody to see. That means anywhere to anywhere connectivity possible, theoretically. Next, please. This already being taken and this innovation is going on. Globally, it's going on. And that means few thousand satellites connecting anywhere to anywhere on the Earth. It is keep happening. Already good number of satellites have been launched in a competing thing. Good business model exists, a good technology exists, and definitely it's going to make very big impact, having done the way in which it has done 2G, 3G, now 5G when it's emerging, anywhere to anywhere India, anything to anywhere in the globe, anybody to anybody, anything to anything, anybody to anything. I think that is the connectivity. Machines, man and machine will be connected in a seamlessly. That will revolutionize the way in which things are coming, starting from classroom, going for the aerospace or the medical. Very many industries, I think this infrastructure, space infrastructure is going to revolutionize. And this is already it's keep happening. I think in the coming months, we will be seeing its own effect. This is a global scenario. What is Indian scenario? Next, please. Yeah, Now, that means the summary is emergence of innovation, convergence, Indian space. What is that we are trying to see? Is one side, as I told here, science research, basic research is there. Converting the technology, engineering, India specific what we can do, and what it can be applied. What it can be applied in terms of the connectivity, remote sensing, navigation, meteorology, telemedicine, teleeducation, Industry 4.0, 5.0. That means enabling machine to connect, man to machine to connect, making digital governance. I think all the things to happen, the emergence of innovation and convergence in Indian space is going to play a major role. How does it going to do? Next, please. Yeah, you have seen the globally how they are going to connect. This view graph is trying to tell how India from north to south, east and west, across the length and breadth of India, we have our own solution. The latest satellites of 6 tonners launched and many satellites getting launched. It will enable not having so many satellites. Previous configuration is called for 2,000 satellites called for global coverage. But Indian coverage, I think we can have the limited satellites of geostationary, our own solution. This will enable to connect anywhere to anywhere India. Our digital governance is possible. And this versus the global, whatever the connectivity is there, that is another way of seeing. That means India, anywhere to anywhere you can connect. This to another global connectivity, also another thing possible. That means we will have our own sovereignty. Beyond that, our global connectivity also possible. This is how we have to have our own self-reliant connectivity. Then we have the global connectivity. I think this is how the Indian space system is going for communication point of view. This will have lot of things will happen with respect to India's governance, India's the border seeing, India's home security, India's weather, whatever messages have to go across length and breadth of India can be covered in a much better way. Next, please. Yeah, having told just one or two example, overall umbrella, like whatever you have seen, the NIOT, what it is doing for the ocean point of view, Indian space program, it is emerging in much better way, even beyond the arms of within ISRO, it is getting wider open to go for the society to make the systems for the societies on its own. I think it's happening right away. But under the broader 4 umbrellas, one is you need required space infrastructure, either for Earth observation, communication, navigation, or space science and planetary missions. To enable the space structure, that in terms of satellites or probes, you need the space transportation, launch vehicles, PSLV, GSLV, reusable launch vehicles, many things are happening. But when these two things are happening, how it going to help the application, space application in terms of Earth observation, as I told, various things, required instrumentation to do that. That will come as a space application. But who will do all these things? How to do all these things? You need a human manpower, you need an infrastructure, so the capacity building. So this under these 4 pillars, today the developmental applications happening using a space assets and a huge space assets. I think today India is one of the leading countries. I can easily tell in the first 3-4 positions, definitely India is there with respect to making the satellites, to launch the satellites and operating satellite infrastructure, excess of what ISRO can handle. So that is the one being now offered to the private industry, academia, who can come and use it not only for Indian context. The self-reliant India space point of view, yes, this is giving. Beyond that, it gives an opportunity. India aerospace making a presence globally. Globally means need not be all the countries, but definitely a good number of other countries. You know that India launched many satellites, not only for Indian satellites. India launched the satellites to other foreign countries. Can you guess who is the highest number of satellites launched from foreign land? Actually, among the few hundreds of satellites launched from foreign country coming and launching here, US stands first. US satellites also, there are the reasons why they have to launch from Sriharikota, why they have to launch from PSLV. We have an attractive solution sitting here. That means we are self-reliant for our own launch vehicle under the foreign umbrella, and we are enabling for the global system. SARC nations, we enable launch the satellite. Our satellite SAARC countries are making use. Like that, many things are happening. Weather forecasting, our own satellites also used for the global weather model. Our satellite sensors are going there. Next, please. Yeah, while doing, I think these are all the various families in terms of communication, observation. These are all the space sensors right away there in the space in various forms of our satellites. These are all the satellites names. More than 50, 60 satellites are there in space today functioning in and around India and globally. And one is around the Mars, another one is around the Moon. Also, it's working for our thing. That means self-reliant India. To make the self-reliant space, it's keep happening right away. Next, please. Yeah. Now, what are its capabilities? I showed one communication point of view, what we can anywhere to anywhere we can connect, and that can give the solution for the digital India, digital governance point of view. Very many things you can connect it. But now beyond that remote sensing is various ways we will tell. You will say how smaller object you can see, and how spectrally you can deviate and see, and how that the air column you can measure. Like that, very many parameters are there. Just giving one example of Carto 2S, a previous generation satellite. 65 centimeter resolution. I think this is one of the cities, Dubai, we have taken. This gives just an example of its capabilities. What it's capable of doing. Next, please. Yeah. Now, from there, now today we launched 25 centimeter resolution satellites. That means what we have seen previously, now you can zoom and see. Okay. That's capabilities keep coming now. Okay. That means finer and finer resolution systems you can see. This has a huge potential, how you can make use of it. I don't want to divert too much, but I'm telling about capabilities what exist. Using this, you can do very many things. There is image processing, cartography, town planning, very many things we can do it. Next, please. Yeah, this is another example. That is what we have seen previously small. Now we are able to expand it and see in a zoomed condition. Next, please. These are all 500, 600 kilometer height. Now you can see almost the traffic in a city we are able to locate. Okay, next, please. Yeah, in a color also we can see that. Next, please. Next. Yeah, this is another example. This is not point of view. So this is now your meteorological satellites not only helping the relaying the weather monitoring buoys or remote terminals of weather, whatever it comes, parameters coming, temperature, wind velocity, the moisture content, whatever the parameters are coming, taken to the satellite and it plays back, which other users like IMD make use. And this beyond that, it gives today we are capable of taking every 15 minutes, the way in which we are putting our two eyes of the satellites, every 15 minutes we can take the globe picture. And that way, you are trying to see the wind vector moving, the cloud formation, cyclonic eye formation, and that's moments. I think today when you are able to see that means this capability exists within us. That means the way in which you program, each one can take within half an hour, the whole globe can see, but intermixing this way in which you are scanning the whole globe, how you can see and how you are able to see the wind velocities and other parameters, including the cloud motion, we are able to give the information there. Next, please. Next, you can go next. Yeah, this is basically, that means our weather forecasting point of view, we are self-reliant. Getting along with the other agencies, seamlessly getting along with other agencies, whether they're carrying their data or providing the data from the space, it is happening, self-reliant for meteorological, for our purpose. We also feel for the global welfare point of view, our data goes, because global monitoring when we have to do that, it also called for, that means international cooperation point of view. Yes, we may also take that data, but our data also goes, not only from 36,000 kilometers, we have a good number of other missions like ocean color monitoring, ocean wind vector, and the scatterometer. Yes, we told there was a sea level increase, and over the sea, what is the temperature profiles. These are all the things across the globe also being shared. So we play self-reliant with respect to what we called for, and again play a major role with respect to global weather forecasting point of view, feeding their data for the international body. Next, please. Yeah, this is another way we have seen our economical zone, exclusive economic zone. And this one typical problem, typical issue, what happens is crossing the border. I think you know that the fisherman between India and Sri Lanka, it's one of the nitty-gritty issue. And this basically, the crossing the border, it happens by the fisherman, not aware of the border, one possibility. Another possibility, yes, they may be even aware of the border, but this is not available in our thing, as they think. Another thing is high waves. Another thing is strong wind. These are all the four major reasons why they stray into the other economic zone and getting into a problem. And for that, definitely the space infrastructure, along with the Earth observation, Earth science team, have the solutions. I think they arrived at, and it's working here and it's being going across also. Next, please. Yeah, this is a typical example. This is typical example of how it happens. That means we have our own navigation satellite, and with that, the handheld system of whatever made and given to the fisherman, he knows whether he is within our border or outside. One. Second thing is using other data, as we told, other meteorological data, other buoys, all put together. IISF gives to the ISRO the parameters of with respect to high wave alert, strong wind alert, cyclone warning, tsunami warning. That in turn ISRO uplinks to the satellite, and that reaches to the handheld. Even you would have gone inside, it tells them so that you can come back. Early warning, it goes, it come back. That is one of the reasons. Now you can see the latest things. Fisherman dying in the seas almost become nil, because he has been, even though he has gone inside, specific to them, their local language, this message goes. One. Second thing is, it's not only that, main thing is potential fishing zone advisory. That also goes using the ocean color monitoring of our OceanSat satellite, converting by the IISF and giving back to the information to the fisherman. So fisherman knows within our economic zone, is it possible for him to go and fish a potential fishing zone, so that he need not go for other reason. So this is the way it connects to the society, it connects to the person there for India specific. So this is how the convergence of various facets together we are able to enable. So just giving one of the example of how we can have self-reliant within our own people, serving to our purpose, our people is concerned. Next, please. Yeah, similarly, this is one of the latest thing we have done. You know that along with the pandemic, locust attack 2020 was thought to be a huge issue along with the pandemic. It is coming, but it was thwarted. Satellites, not only the satellites, along with the satellites, another technology drone. The convergence of this enabled. That means using satellites, our wind vectors we are able to get that. Getting the wind vector, how it flows, and that also as a bearing, how this locust will move. The cluster keep moving because it goes along with the wind. The night time it settles, daytime it goes along with the wind. It not go against the wind, it goes along the wind. And that, looking at the pattern, why it has came from Sahara to Pakistan, Pakistan to India, and within India, how it's supposed to move. This prediction comes. So as per that, the drones were deployed. Drones were deployed, such as is a cluster mode, and in between that places you have the locust catching systems kept there. How the science and technologies of various facets are working together, and that way I think they are able to contain the locust spread across India not to happen. Okay, they have been localized. Many of them has been caught, and it is done. That means here another science and technology, India-specific solution is happened. Seeing this, even our neighbors also now try to follow this. Until now, such solutions were not seen. So, a self-reliant for our own purpose, whatever we have done, has having a impact and globally also now. I think the subsequent, because these attacks once in a while keep coming. So when it comes, I think there is another solution, what beyond what conventionally being used also has come out, emerged in the recent past. Next, please. Just I'm giving few examples. So this is another example. Another example is, given the opportunity, how our youth will make use of it. For example, today I myself struggled to connect using our Microsoft team versus my system, because my office had some problem. I have to come this place, my residence. From here, when I'm connecting my home computer versus this, I had some issue. I could not connect through that. Okay, and now yes, fallback only. Now the presentation is being done from SARG. I am only giving a voice over from here. Okay, this is an issue. But why such a reliance is required? Why we cannot have a self-reliant system, our own system? Why not possible? I think this question I raised. These 3 engineers, okay, with the 2 computers, they have taken 3 months, okay, and they came out with. I think next time when you want, probably I can introduce them. It is full and full made in India, and many of my public lectures I make use of their system. And these people, they were working in the computer engineers, youngsters, but they came out with, given the idea, with that goal, few months it has to come. I think they have done it. What they have done? Next, please. For this sort of webinars, what can be done? Yeah. Now this is called Amazing. Amazing. Okay. This is, you look at other Google Meet or Zoom, how it fares, and they spent only $7,000. Only $7,000. But what do you look at here? What are the facilities available elsewhere? They are given. Our own thing. But when I talk with school children, when I talk for the other the public events for outreach point of view, mostly I'm trying to use these people. These youngsters have done fantastically well. That means, given such opportunity, Indian team, Indian mind can do much better, much faster, much cheaper. They have done it. Just an example I'm putting in the part of while presenting. Yeah, next please. Yeah, this another thing. Basically, I'm trying, as I told here, I'm taking across the breadth. I'm not going top, I'm not going to bottom, I'm going across. What are all the possible opportunities, India specific possible, so that we have self-reliant India point of view, what science and technology can do to make our global presence felt, global welfare point of view. You know, India cultivation of banana is huge. Actually, India ranks #1 in the banana cultivation. But in the banana, though in the family wise, we know that from its root to its flower, every part can be utilized, except fruit. Other things are not spent too much. Actually, it is becoming a waste, and it is becoming a burden to the farmer. India has a few hundred thousands of acres being cultivated purely for the banana point of view. Other things, though symbolically people have done, various food technologies are there, various materials can be done. Everything has been demonstrated, but I think has gone beyond that. So farmer is still suffering, and this activity point of it still going on. So what can be done, and what is being done, okay, and what is emerging, indicating what right away we can do, though people have not seen it in a bigger way. Next, please. Yeah, this is keeping whatever I told. The innovation is putting the existing technologies together, what we can do. And fiber processing, basically the banana stem, the fiber can be processed. That fiber, basically look at here, nominally the stem is going to the waste. And from the stem, you take the fiber, and that fiber has very good potential. It is doing even better than the cotton fiber. But cotton, we are cultivating purely for the fiber only, for the cotton textile only. But whatever per kg of cotton fiber, we are spending few thousands of liters we spend there. But here, the stem which going a waste can be converted into a raw material for a textile. This again, just 1% of that waste, how we are converting. Many things also can be done there. Next, please. Yeah, next. Yeah, very many things also can be done using, for example, the core. It can go as something for switcher materials. It is possible to have the liquid fuel because it gives nearly 60, 80, 70% is the stem water coming as safe water. Safe water can be converted into a green fertilizer possible. And so many other things also very well we can do it there. So a lot of potential is existing. To do that, existing technologies all putting together in some form or other, converging together, we are trying to identify a system which can take care of this without affecting the farmer. Farmer really gets the money also, but we can get a huge amount beyond the fruit. Okay, beyond the fruit, even multiple times of the fruit value, I think society will get in terms of textile, in terms of aerospace industry, in terms of possible ethanol, in terms of possible composites, in terms of the possible green fertilizer. Many things it's keep coming out. Next, please. And even using a maida, we can have the fiber content, you add this fiber content and the fibrous biscuits possible. So this is only the technologies, a convergence of the technologies, putting the things together at the earliest to come out with this, along with the pandemic thing, we are making an attempt. Next, please. Yeah, this is a virtual banana waste to wealth plant. Okay, this is the banana after banana cultivation. The stem as it is being taken, like water coming to sugarcane industry. This is the model virtually we built, and how it look like. How it look like. This is the heart of the whole system. Heart of the whole system, such that because within the few days, within 1 or 2 days, we should. After this removal, it will be processed. So a cluster merge system, every 50,000 acres, we will have one such system. The plan is something like this. And that will create a waste to wealth. Okay, this is, you look at here, this is supposed to be a waste. And each farmer is struggling to how to clear the waste, how to make that he is finding difficult. But now farmer will get the money from here. But this is taken, and that is being taken into various products being done there. And it is taken a seed out of it, and the core goes one side, and the core is taken, and the core will be sliced, starting from pickles to biscuit to nutraceutical system. It's possible to do it. Okay, and this is full and full everything in India, self-reliant. I think we are going to the first ever in the world to make a textile totally out of banana, huge number. Even now people are making. I know from my place where I'm sitting, 15 kilometers away, sari is being done today, but it is a very, very small scale. But now we are talking about a large scale, from handloom to a textile, one side. And the other sides, basically, you look at here, composites, it's few thousands of metric tons, it's possible to do that. And another thing is the composite material for aerospace, big windmills, and even the satellite point of view, the lightweight, high strength composites possible to do it, because these are all the things can be done much faster today with this convergence of technologies coming together. Next, please, I think we can move forward. Just I'm giving an example here. What's happening? And while doing it here, I told Industry 5.0. This is another convergence. That means for 5.0, when we talk about here, within the factory, 4.0, we talk about Industry 4.0, 5.0, within the factory, machine to measure, people monitoring, automation point of view, 5.0 done. But here the same concept taking all the way from whatever the cluster I told to the field, banana field, so that we will be connecting using the satellite and the clouds point of view, such that the raw material coming from, not from the warehouse, raw material coming from the field, as I told here, within 1 or 2 days, it should come here, it should be consumed, and get ready for the next one. Per day, I think few hundreds of acres. I think that is a target across India should do that. For that, convergence of that, using this method, integrated management of banana fiber extraction and supply chain. This another team has done it. I told previously, now from $7,000, some people have done. This is also a throwaway price. Farmer will get in his phone when he's supposed to send the system there. When he gets it here, the moment it comes it here, he will get in his system. Yes, for his systems, payment has been done there. Okay, and another way of tracking the whole system from where the fiber has been come in for the overall green with textile point of view, that also helping that. So the convergence of many things, keeping one side farmer, another side in aerospace industry, which is waiting for this material to come. I think it's going to be seamlessly connected. It is not a theory, it's keep happening. Okay, I think we are only few months away from such things to happen in India. Next, please. Yeah, the heart of the system is this machine. I think this machine is happening from my city, from my sitting place to 15 kilometers away. The heart of this system is being now tested using the from the field, whatever taken the stems are concerned. Next, please. Yeah, now beyond that, you look at here, I told sometime back the satellite and drones together, how it helped for that. Now, the drone technology is India specific, something can be done. Again, a convergence of various sensors. When you talk about here, I am starting from ordinary camera, video camera to hyperspectral camera, or for radar system, or for hyperspectral system. Very many system possible. Not only seeing, even dispensing the infections, infecting the fertilizer, something like that also possible. Even strategically also possible. Okay, drone remain the common thing, like a satellite remaining common thing. It can be used for communication, remote sensing, meteorological, navigation, going to the moon or going to the Mars, something like that. Drone also can be done, being demonstrated using various sensors fitted, various actuators fitting there. It's keep happening. Next, please. So India specific, many things can be done. Next, please. Yeah, I think some of this view graph has gone, and this is can be done, not can be done, it's being done. Okay, I think this is what's happening just in Anna University, distributed UAV image processing. Whatever I told, if 25 centimeter resolution from satellite imagery, many things can be done. But this gives few millimeters resolution, specific term areas, so that in that you can do much better in the field. Let us assume something is getting infected, is happening. You localized is possible to identify at the earliest. Identify that, and that place something that place alone infected you do is a better way of doing precision farming. Precision farming not only for the water giving precision water drip irrigation, even the precision way of infectant seeing is another way of doing. So it's a very many things possible, and towards that image processing system network way it's sitting here. Next, please. Yeah. Now, similar way you look at here, that means cipher physical system. That means the system is sitting elsewhere, but physically you can connect it elsewhere and we can keep doing what I was trying to tell here. It can be done in the farm. It was started, originally plowing was different way, tractors were given. Now, unmanned tractors are there. Similarly, in the cultivations point of view, so many things are happening, I need not tell. But now you look at here, the convergence of these things, all the things put together in the farm to food. Okay, when the plowing to all the way, whatever food coming to the table, that is the farm to food. An emerging innovation is nothing but convergence of what all technology is told here, putting the things together. We can enable Indian context much better way. Especially post-pandemic, I could see in and around places, labor-intensive works, labor is not available in the field. But definitely automation is available. It's possible to populate, but still someone has to operate. So here only cipher physical system comes into picture, even the drone operation point of view, fertilizer speeding point of view, and drip irrigation point of view, food processing point of view. And again, as I told, our banana fiber point of view, raw material to this, how we are tracking. Similarly, food processing institute to the supply chain, whole chain can be seen there. That means whole thing, like our digital governance, what we're talking about here, this thing can be done, farm to food, everything can be connected well way. And today our youth is very potentially, definitely we can do, given the problem. As I told one example, given the problem, definitely they will do. And bringing the things together, a very knitted system can be done. Wastage, very recently had been in the Institute of Food Technology. They claim nearly 200,000 lakh of rupees, crores of rupees, 200,000 to the 2 lakh crores of rupees worth food products, food grains are getting wasted. Okay, that is a huge thing. The waste to contain also, I think this can enable much better way. That means you have one side cultivate you can better, and another side management of water is better. Another side with the less labor we can do it. Another side the wastages you can contain. So all the put together, it has a huge potential. The convergence of these activities is concerned, and huge potential the youngsters can do better way. Next, please. And these are all things happening. I'm not telling it's not happening. It's happening. Now we have to, numbers have to increase because this has a social relevance. This has a business. This has society's acceptance also will be there. This one such thing is integrated modern agriculture. Some places people are already doing, but it needs to be done in much broader way so that every farm can come in this part of thing is concerned. That means satellite to the end field via farmer. I think these things are getting connected. Next, please. Just giving an example. Yeah, this is just few kilometers away from there. Now the farmer is operating a drone for spraying the infectant. Okay, insecticide point of view. Yeah. And you can see the health hazard for him is now almost zero, and only the proper ratio of what has been told he will go, and it is much faster also. Of course, there it is faster. Here the network is not faster. That is a different story. absolutely saying it. Okay, I think you can move forward. Just giving an example across the breadth. So this is another example. For example, India is known for textiles, but issue is it also creates some problem. That means you have the dyeing industry, both tannery and textile. We have lot of effluents coming that is polluting the water or other things. Though some existing ETP systems are there, they also have their own issues. Their own issues of it calls for huge evaporators. Evaporators make use of a coal. So that coal, because of that, carbon emissions kept happening. Not only that, after evaporation, good amount of sediments happening. That sediments again creating a problem. They are solid waste. So this issue is not totally taken away. Its issue is still there, but they are spending money for this purpose. So another innovative, just existing technologies going in a slightly different way. Some hydrolysis, other health systems are happening there, such that evaporators can be dispensed with. And the system, nothing goes waste there. Okay, whatever the solid waste can be converted. The solid waste will not come here. That will be converted into a usable chemical back into the dyeing industry itself. Water can be circulated within that itself. So another totally different system. Not systems are not new, but systems are connected in a slightly better way. Evaporators versus some other system coming here, and that way is another innovative thing going on. When this happens, definitely we will have a good answer for the tanneries and textiles. Very many places where the effluent treatment plants are today, it's creating an issue that can be avoided. So this work also is one of the potential things it can be taken and proceeded. Next, please. Yeah, like that I can enumerate. Industries, food processing, manufacturing industry, education and construction. A convergence of existing technologies in a proper way, very, very innovative way, India specific, we can do a lot more things. And we are seeing, for example, today we are this festival itself, we are seeing different way. Very many activities, because cyber physical system ensures not only the text delivery, voice delivery, even actuations possible. So that are putting the things together. Very many things it's possible for Indian context. That will make India self-reliant. Not only that, India will show a way how India doing globally. It can create a thing. For example, I know when the project is going for the banana industry, already from outside India, good number of inquiries are there. Whether they can do such things in their countries. Next, please. Yeah, that means what all I put together is we need an innovative culture. Okay, the innovative culture is there, but innovative cultures there is a paradoxical. I think that's how the people who get into the innovation, the people who govern the innovation, I think they should be aware of that. That means in the innovative culture, a tolerance for failure is required. However, there should be intolerance for incompetence also should be there. This is what I told paradoxically. Tolerance for failure definitely should be there, but intolerance to incompetence is very much called for. A willingness to experiment should be there, otherwise innovation will not come, but there should be rigorous discipline. Physiological, psychological safety safety should be there. I think there is some problem here. Comfort with a brutal candor will be their other side. Collaboration is required, but still individual accountability is called for. Doesn't mean something failure has come, somebody is showing up, fingers elsewhere, it's not be there. Individual accountability should be there. Flatness in management, definitely called for in innovation, but still strong leadership. There is may look paradoxical, but that's what all about innovation. That means tensions created by this paradox to be managed to create an innovative culture. I think that is what India needs today. If we bring in all the things together, definitely sky is not the limit. Ocean depth is not the limit. I think we can do wonders. Next, please. Just give an example. I think time is running out. Just giving an example. I don't know whether you're able to identify that person with a long beard or other thing. And another than Vaisami Anadure. Just 3 months into joining ISRO. Okay. I myself was telling what ISRO is doing. That because that time satellite was launched from outside. Satellites were done by outside. What we are doing here, I was questioning. You are only operating the satellites. So then actually from this position I retired. Professor V.R. Rao, okay, he took all the things there. Then he wrote it back. Whatever you want to suggest, you come with a suggestion, and like that. Something I scribbled and went there. Then he told, okay, whatever you're telling here, I am giving a responsibility for you. Can you do it? 3 months into ISRO. Believe me, it is given. And of course, it took for me nearly 4 years to do it. But that system is working even today. Okay, that means the systems understanding, putting everything together in a simulator form. That is something called flight simulator for satellites. First time we have done here. India self-reliant in the satellites point of view. I think that has happened there. And today you look at here going to Mars, we have gone in successfully because we relied heavily on the software satellite simulator, what to be done, how we are going to operate, how you will reach, everything we have done. That's why never ever anybody has done one launch to the moon with a single model. I think India only has done it. That's the reason why our budget is less. Still, in spite of that, we won the first attempt itself. America succeeded in 5th attempt. Russia was its 9th attempt. China had to succeed. Japan had to succeed. India succeeded strong budget. Somebody allowed a rebellion type of fellow to do his idea, nurtured it. What all I told innovation, I told that I think all the paradox together, my left side, right side, how it matched here, I was trying to tell. Just an example. Next, please. Yeah, that again, inquiries, questioning the thing now. You know that we are all, when the young boys, Apollo missions were there in 60s and 70s. They landed on the moon and searched for the water, declared nowhere water on the moon. Yes, Chandrayaan went 2018, but only rephrased the question. Okay, they landed on the moon, searched for water. Now we searched for water to land on the moon. Okay, when we searched all around the moon, we have discovered water, which they have failed to discover because they landed in wrong places. Where all they landed, all that places, water is not there even today. But where they have not landed, the water is seen. Afterwards, you can see 2013, one more vehicle went and landed where we claimed water is there, and that confirmed, yes. 4 years later, 2009, we discovered water on the moon and near the poles, and subsequently the whole globe is telling, yes, what we have done is correct. Okay, so this is India's innovation created a global impact. We have done it. The discovery of water on the moon by Chandrayaan 1 has reopened our journey to the moon. Next, please. Yeah, now a very big camp plan is going on across the globe. 2020-28, back to the moon. Okay, starting from next year onwards, missions will keep moving. Actually, Chandrayaan 2 supposed to have in that first to soft landing, but somehow we missed it. I think we'll make still an attempt to go that point of view. But still, now this time globally, the impact is people are trying to go back to the moon in a much bigger way. When Chandrayaan is going there, as you can hear, so many Chandrayaans also will moon there. That means India's presence both in Samudra and in space, I think it's the coming years is there. The budding engineers and scientists, for them, have a watch. You have plenty of opportunities, and you can be part and parcel of India's hand to do in the global presence. Next, please. Yeah, this is very ambitiously today, the going back to the moon point of view, return to the moon, very ambitious systems are being built now. Next, please. Yeah, this is India is working for how when we go there, how our habitats would look like. Okay, we have a lunar surveillance we made. That's also a national international pattern. When that, using that, how the 3D printing, igloo type of things we can make. I think already the work, we are doing that job from ISRO point of view. Next, please. Yeah, I can keep moving. Yeah, this is another thing when we are launching. Okay, no problem. So now when we are talking about this, you cannot come to the top alone. Okay, we have to cultivate the people all the way from there. So that's why Tamil Nadu State Council Science and Technology, I think many DST things also we are making their help also into that. But structurally bringing the thing out, science outreach all the way, school level, what they only awareness, and try to bring them into a limelight. We bring them in the mainstream for science and technology point of view, school level, college level, then young scientists and researchers, and today's applications, and rewarding, recognizing them. And another thing is top research centers. Now what we are talking about is, as I told, for banana research and for BTPs, many things being done there. That means you need the raw materials keep coming from the bottom. So yeah, a structured way of bringing this is keep happening. So it is up to the people to start using from the school, because you have a lot more to reach up there. Yes, today's 2 lectures you look at here, you have what opportunities we can do at the top when we are coming. But further to come, if you start able to start at enter into that any one of the level, you have a lot of opportunities to come up is concerned. Next, please. Yeah, this whatever I told in some other form, that means to start with the give support, people will make an effort, and there is a learning. Failure learning is there. The results will come. This is an engine, a strong innovation culture, the engine that drives constantly to get better, move forward, and innovate. I think some other way symbolically I'm putting. You can keep moving. Next, please. Yeah, this basically what I previously told, the innovator and society and government support related work if you do, money is not an issue, because today, in spite of first pandemic, in spite of no money has come from government of India organization, using a private funding alone, whatever the project I told, I am doing along with the private funding. Just I'm telling you. So it's assuming government will support subsequently, because we cannot lose the time. Time once lost cannot be gained. That is the reason we are doing. So funding point of view, the society relevance is there. Business is there, we are able to show, definitely fund will come. This is my experience. So the young researchers, this is my saying. You have an idea which has a social relevance, and definitely you have the economy also, definitely people are ready to give fund for you. Definitely you can go lot more. Next, please. Yeah, this is the example. I am putting it there. Keeping a IIITDM Kanchipuram and NRCB Trichy, the banana project, what I'm doing is using some of the industries together, how it goes, waste to wealth. Next, please. Similarly, for the another project, whatever I told, for innovative culture, the consortium mode, HLD for ETP. Anyhow, SERB is there, but this year still funding has not come. But in spite of that, work has to move. I think we are keep moving by the industry funding is concerned. Somewhere we'll catch it up. I'm hopeful somewhere we'll catch it up. But still, even if not coming also, we can move forward, because it has to sustain. That model is given, definitely fund is not an issue. Today, it's basically how you are able to get an idea, how you are able to convince the people, how you are able to implement. These things are there. Convergence of money, along with the technology, along with the societal need, along with the impact. I think it's possible. That is a message I would like to tell during the curtain raiser. And definitely, these festivals is to showcase such a things. Possibly in subsequent years, we'll be able to showcase much better thing, because today youth is emerging. Definitely society also looking forward that post pandemic is definitely, we expect a lot more to happen in India. For that, India will become self-reliant, science and technology can do a lot more. We will make not only our thing better, we'll make our global wealth also, global welfare also, definitely we can take care. Ocean to space. So Indian science and technology is poised for self-reliant India and global welfare. Thank you. Thank you very much for the opportunity.
Thank you, sir. Thank you for the enlightening and inspiring presentation on the wonders that can be achieved using effective innovations in science and technology, with examples from every possible field, which is highly motivating, especially for our young audience. We are honored to listen to your lecture today and also to have you with us today. Thank you so much, sir. Our SERC's Nodal Officer for IISF, Shri N.G. Bhagawan, has been working tirelessly in the background for the past few days by contacting many schools and colleges for efficient outreach of this program. I now request him to propose the formal vote of thanks.
Namaste. I hope you are able to listen to me. Thank you. It has been a fantastic journey today through wonderful depths of oceans up to the moon and beyond. That way I can put it in a nutshell. We have to thank you very much, Dr. Swami Annadurai sir. Your lecture has been package of wisdom. You have not only taken us to the space, you have also taken us to the agriculture, to the banana waste, and whatnot. The loveliest definition you have made for science, you said science discovers what is there. It's a discovery. It's an invention. Whereas you differentiated very aptly with reference to engineering is that engineering makes what is not there. That is all the GDP, creation, production, everything comes under engineering. This is a wonderful difference I have ever seen between science and engineering, and absolutely hats off to your wisdom, sir. You have also brought the wonderful comparison between inventions and innovations. We are all totally delighted. We are taken to elsewhere, in fact, in the space of our mind, with reference to our wisdom and knowledge, whatever we possess. Definitely, you have made a great impact. To think absolutely creatively for making important self-reliant approaches to the country's productivity. Thank you very much, sir. We are really honored and we are absolutely taken back with your wonderful approach of covering so many things within the given limited time. Thank you very much, sir. Madam, definitely you have also taken us to the very depths of oceans. And this is I'm coming to thank our director to identify both of you to bring here to this forum. But it is our responsibility, duty, honor to thank you for taking us the unknown fields of ocean technologies. OTEC, desalination, and your service for the remote islands of the country. It's all absolutely country really has to pay back to you people like anything with great honors. And this is a wonderful forum which has brought you here. And how can I miss to thank our director to identify such a wonderful personalities with such a great topics, which has covered so much of wide, really from depths of ocean to the moon and beyond we have traveled. It's a great journey today. I'm very thankful to Professor Santosh Kapuria for his wisdom of making things work like this. This is a simple example how our director gives us the direction. And coming to the Director General, he has been so very nice, and he has been down to earth personality type of person, and he has been not only with our SCRC for this event, for almost all 38 laboratories he has been personally attending. It shows the leader and his commitment. So we are really fortunate to work under such leadership. And my entire team, including the head of division of our team, it is called Skill Development and Human Resource Development Division, SHRDD. The head of SHRDD, Dr. Rajesh Shankar, has been guiding us in formulating this program. So our thanks goes to him. My colleagues, Sri Sundaramurthy, Dr. Mr. Ashok Kumar, Balakrishnan, and also to the team of ICT, head of ICT, Mr. Ananthakrishnan, to make the things to work on this visual platform. Then our thanks is also due for the BKMD team for all the support they have given, our administration and their COA, Controller of Administration and team, Finance and Accounts Officer team, then Stores and Purchase Officer team, and so many people. We thank every one of my colleagues for making it a great success. I'm sure because this is coming on the YouTube. We will be definitely taking to various schools in future also. It will be recorded. It will be live there on our website, on our SERC's official website, our social media. Definitely all the children will have great learnings from this simple forum. So I thank you all, one and all. Thank you. Namaste.
We have to thank Bharti Priya and Bhagavan
Yes.
for putting this up, this good program, and Bharti Priya for comparing. Thank you.
Thank you. Thank you.
You are muted, Bharti.
Thank you, sir. We have now come to the end of this event. On behalf of SERC and CSIR, I once again extend my heartfelt thanks to all who have joined today on this IISF Dr. Abdul Kalam Vigyan Yatra come curtain raiser event. Thank you all. Stay safe and goodbye.
Thank you very much.
Thank you. Thank you.
Thank you.